In this lesson, we're going to continue looking at Pythagoras, but we're going to look at the situations we did not have yesterday. That is, where we want to find one of the other sides. Before we start, quick review from yesterday. Pythagoras allows us to find the unknown sides in a right triangle. It uses the formula a squared plus b squared is c squared, where c is always your longest side. In this case, c, also called the hypotenuse, must be across the right angle, has to be over here. A and B, interchangeable, don't really care which one's which, as long as you call them A and B. So, if you plug them in the formula, a squared plus b squared equals c squared, our objective has always been numbers on one side, letters on the other. Exactly what we have. We're ready to do some math. Okay. 15 squared is 225. 18 squared is 324. Add them together, we got 549, but that's c squared. We want c, so we got to take the square root of 549, and we end up with 23.43 for c. It's exactly what we did in the previous lesson. We're solving the unknown hypotenuse, the long side. But it's also possible to figure out the other side given the hypotenuse and one of the legs. So we're going to do the same kind of idea, except here we're going to have to find the missing side, which is not always side C. Just move some things around so it's easier to work with. Okay, job one, find the right angle so you know where C is going to be. A and B are interchangeable, so I'm going to call this one A and the missing one B. So what is my situation? Well, my formula is a squared plus b squared is c squared. But I know that a is 8. I don't know what b is. I'm going to call b still. And c is 10. And we've always said with algebra, when we have letters in equations, we want letters on one side, numbers on the other. We don't have that. We've got to fix it. So I'm going to take the 8 squared, and I'm going to bring it over here and do the opposite. I've already got 10 squared. When the 8 comes over, it becomes a minus 8. It was adding, now it becomes subtracting. And I've got this situation where I have numbers on one side, letters on the other. Okay, ready to do the same math we've been doing now. Square it and square it. This time we're going to subtract. 100 minus 64 is 36. I want to get b, so I've got to take the square root, and b is 6. And there we go. It's been solved. Okay, we'll try another one just to show you. Same ideas. Try B up here. Okay, which is side C? Side C has to be my long side, across from the right angle. That's got to be C. So A and B are interchangeable. I'm going to call this one A and this one B. If I do it the same way every time, it makes it a little bit easier, right? A squared plus B squared equals C squared. Oh, I got one number in the wrong spot. That 18 has to move. I'm going to move it by bringing it over to the other side and turning it into subtracting. I'm going to do my math now. 82 squared, the big one, 6,724. 18 squared is 324. Just move this guy out of the way over here. If I subtract those two things, I get 6,400 for b squared, but we want b, so that's square root. And it turns out that b is exactly 80. And we have units here, so we should probably shove the units in. Okay, so same problem, different order. I get you guys to try one, so pause the video, see if you can figure out how to do C. Okay. So my hypotenuse, my A, my B, A squared plus B squared equals C squared. I want to get the B by itself. So I'm going to bring it over and subtract. I'm going to do my math now. 32 squared is 1,024. 18 squared, oh, I've seen that number already once today. 324. If I subtract, I get 700. But that's b squared. We want b, so we have to square root. And b turns out to be 26.46 And we're talking about centimeters this time. It's okay to get decimals. Most of the time you will get decimals. I just start with two nicer ones first. Okay, this idea of figuring out the missing side is really handy. We use it in all sorts of situations. We're looking at an example right now of how we can use it when we talk about the shapes we've been talking about, perimeter and area. So yesterday, or no, sorry, 2 days ago, we talked about perimeter. The perimeter of a shape is a distance around something. So if I wanted to find the perimeter of this weird looking shape right here, I would have to add up all the things on the outside. So for instance, I got to add up a 4 followed by an 8 followed by another 4. I know it's 4 because I got those little dashes. They tell me things are the same. Followed by this side and this side. But they didn't tell me what they are. They said they're equal because they gave me the double dash idea. Double dash and double dash, but they didn't actually tell me how big they are. I'm going to have to figure them out before I can add them to my perimeter. So I can put my plus signs in, but I need to know what the numbers are. How can I do that? Well, they gave me a hint in this diagram. If you look at the dotted lines, in fact, let's just redraw it right here. They've created a right triangle. And they said that this side here is 3 on the edge there. So that's 3. And the top, this piece right here, has to be half of that. So it's got to be 4. I'm missing the third side. And the question is, which side is it? Well, if this is my right angle, across from it, C. So this must be A and B. And if I use my formula, 4 squared plus 3 squared is C squared. In other words, A squared plus B squared is C squared. It's the Pythagoras question. It's a nice one. All the numbers are on one side and the letters are on the other. So I can do this one pretty quickly. 4 squared is 16. 3 squared is 9. Add them together, we get 25. I want to know what C is though, so I have to square root 25. And it turns out that C is 5. So if I go back to my diagram now, I can add something to the diagram. I can say this double dash right here is 5. So is that one. Which means in my perimeter idea, I got another 5 and another 5. Put it all together, 4 plus 8 plus 4 plus 5 plus 5, and we get 26 meters. Okay, all the things on the outside added together. And the second half of this question said find the area. I'm just going to erase some stuff so we can see what's going on here again. What do I see in this picture for area? Well, I really see two different shapes. I see a rectangle and, I'm going to move that line down a little bit, a triangle, right? Let's fix that. Here's my triangle and a rectangle. So if I want to find the area of this shape, I actually need two things. I need the rectangle plus the triangle. The formula for a rectangle is length times width. How long is it? It's 8. How wide is it? It's 4. The rectangle is 32. Area for a triangle is base times height divided by 2. Like I said, with our base and our height, they always have to meet at the right angle. Well, I see the right angle. It's that box right there, right? How tall is this triangle? The height is 3. How wide is the triangle? Or the width is 8, the same as the rectangle. So 8 times 3 divided by 2. And so I'm going to add, move this 32 down here, and 32. Okay, 8 times 3 is 24, divided by 2 makes 12. 32 and 12 make 44 meters squared. Okay, so we've used Pythagoras. Pythagoras in general will be used for either area or perimeter, probably not both. In fact, it can't be both, but you probably need it for one of the two when you're looking at things that have triangles in them or things that have right angles in them. Okay, that's the end of today's lesson, second part of Pythagoras. We're going to try today's sheet, more Pythagoras questions where we're solving for B or A, if you will, working Pythagoras backwards. Then we'll go back to our shapes some more. We're going to talk about circles and other shapes we can deal with.